Hello folks, and welcome back to another lesson. Today we're learning about systems of inequalities. But to start off, I want to bring us back to compound inequalities, thinking about how did we shade a compound inequality, and what was the significance of that? Well, to graph a compound inequality, we looked at the area where the inequalities overlapped. What was the significance of the shading? The shading was all the answers that could be true. They were all the possible solutions. So then, what are compound inequalities? All a compound inequality was two or more inequalities put together. So something like minus 2 is less than x is less than or equal to 3. We went to minus 2. We made an open dot because it's a less than sign. We went to positive 3. We made a closed dot. And we said it's everything in between these two, right? This is the same thing as minus 2 is less than x, and x is less than or equal to minus 3. X is less than or equal to minus 3, meaning that everything to the left of minus 3 and everything to the right of minus 2. Normally, minus 2 would be everything that way, 3 would be everything that way. So we shade the area in between. Those are the points that are our solutions. Now the same is pretty much true for a system of linear inequalities. All that's different for a system of linear inequalities is we're looking at two or more linear inequalities, or inequalities with two variables. Now, what are our steps for solving a system of linear inequalities? Well, step one is going to be graph one of your lines, graph one of your inequalities. Now, I would say do not shade for this. Just put arrows in the direction of shading. So for this first one, we're starting with y is less than negative 1/2 x plus 4. So we're going to go up to plus 4, and we're going to go down 1 over 2, down 1 over 2. I'm going to graph this line. Now, is this line going to be dashed or solid? That's right, this is dashed because there's no equal sign underneath. So we're going to dash our line. And that's the equation y is equal to 1/2 x plus 4. Now to figure out what's less than it, we test the point 0, 0. 0 is going to be less than 4, so that's correct, meaning that everything we're going to shade is going to be underneath this line. That would be the area we would shade if this was just one of these. Our second step is going to be graph the second inequality. And we're going to do the same thing where we're going to use arrows instead. So for this one, we start at minus 5, and we go up 3 over 1, 3 over 1, and up 3 over 1, so on. Now is this one going to be dashed or solid? That's right, this is going to be solid because we have the equal sign underneath. Now we have to figure out which way we're shading for this one. For this one, let's go with 0, 0 again. Is 0 greater than minus 5? It is. So we're shading everything greater than this line. And now step 3 is going to be shade the overlapping region. Shade where the arrows both point to. This graph has been broken up into 4 different parts. Is this top part up here, that part only has one set of arrows going towards it, so that's not going to work. This part over here has no arrows. This one only has the red arrows, and this has both sets. So this area in here is going to be our shaded region. This will be all possible solutions to this system of inequalities. All right, let's get some practice in. You're going to start with me doing one, then you're going to go ahead and do problem 2. For this one, we're left with y is less than minus 2x over 3. So we're going to start at 0, 0. We're going to go down 2 over 3, and down 2 over 3, and so on. We'll make this as large as possible. 2 over 3. And we're going to dash this line. So this is our first line. Now we have to see which side we're going to shade. Can't use the point 0, 0 because it's on the line, so that won't tell us anything. Instead, let's choose something like 0, 10, way up here, to test our point. Is 10 going to be less than 0? No. So we're going to shade in the opposite direction. We're going to shade going down. Okay. For this next one, we're going to have to convert this into y is equal to mx plus b form, slope-intercept form. So that'll become minus 2y is greater than or equal to 5x plus 10. And now we're going to divide by negative 2. But we have to be careful. What happens when we divide by a negative with an inequality? We have to flip the inequality. So instead of this being y is greater than or equal to, this one will become y is less than or equal to 5/2 x plus minus 5. I'm dropping negatives all over the place. So this should be minus 5x minus 5. We're going to go down to 5 minus 5. And we're going to go down 5, 1, 2, 3, 4, 5 over 2. We're also going to go up 5 over 2, up 5 over 2, and up 5 over 2. Now we're going to go ahead and graph this line. This one is solid because our line is less than or equal to. Again, we're going to test a point. Is 0 going to be less than or equal to minus 5? It's not, so we're going to shade everything underneath this line. And looking at this, we have 2 arrows in this bottom left region. So that is going to be the answers to our inequality. Right. Go ahead and try problem number 2. Remember, x is greater than minus 2 will just be a vertical line. Now for this one, x is less than minus 2. We're going to draw a dashed line going up and down at minus 2. And greater than. 0 is going to be greater than minus 2, meaning we're going to shade to the right. For the other one, we have 4x minus 3y is greater than 12. So we're going to need to convert this into slope-intercept form. Let's see, we get minus 3y is going to be greater than or less than minus 4x minus 12. When we divide by minus 3, we have to flip this inequality. So this is going to become y is greater than 4 over 3x plus 4. Let's go ahead and graph this line. So we're going to start at 4. We're going to go up 4 over 3. We'll keep doing this the other way. We're going to go down 4 over 3, down 4 over 3, and so on. Then we're going to graph our line. Now we have to figure out which way we're going to shade. For this one, let's look at this equation. Is 0 going to be greater than 4? 0 is not going to be greater than 4, so we're shading everything above the line. And what's the area with 2 arrows in it? It's this top middle area here. So that's going to be our solutions. All right, that's how we graph an inequality, given that we have 2 inequalities. Let's go the opposite way. Now we're going to write a system for the graph, given that we have the graph. Now, how are we going to do this? Well, let's figure out which way each of these lines are shaded. This one appears to be shaded up. The red one appears to be shaded down. And this green area here appears to be our overlap. So let's figure out how to draw this red line first, how to write that red line. We're looking, looks like 1, 2, 3. Our intercept is at 3, and we go up 2 over the course of 1. So this first line is going to be y is, we're pointing down, it's less than 2x minus 3. And what's this other one going to be? Well, it looks like we cross at 2 here, and we go down, what is that? Looks like 2 for every 1 we go. So this is going to be y. Are we looking greater than or less than? This is everything above, so it'll be greater than. We're going down 2 for every 1 we go, so minus 2x plus 2. And that would be our system of equations for this one. Go ahead and try this set. What are our equations going to be? Looking at these, it looks like our blue line is both solid, so we'll need to remember that, and we're shading above it, whereas our red line, we are shading below it. Let's start with the red line. Looks like our y-intercept is up at 1, 2, 3, 4, 5, so we're going to have 5, and we're going down by 1 for every 2. So this is going to be minus 1/2 x plus 5. Now is y going to be greater than, equal to, less than or equal to, greater than? Well, we're pointing down, so it looks like this is going to be less than, and it's dashed, so we do not have an equals sign. So there's the red line. What about the blue one? Well, for the blue one, we're going to start at the y-intercept. We see our y-intercept is minus 1. Our slope, it appears to just be 1, so this is going to be x minus 1. And we're shading everything above it, and our line is solid. So our equation is going to be y is greater than or equal to x minus 1. Now let's do some application. Let's say you have a friend who makes $15 per hour at his first job and $11 per hour at his second. His goal is to make at least $600 per week, and he doesn't want to work any more than 55 hours a week. We want to write a system of inequalities and graph these. So this looks a lot like what we did in the last lesson where we were dealing with word problems. So let's call x the number of hours at the first job. And let's call y our second job hours. We know that total, we want to work no more than 55 hours a week. So the time we spend at our first job plus the time we spend at our second job, we want to be no more or less than or equal to 55 hours a week. And then for the other part, we make 15 bucks an hour at the first job and 11 bucks an hour at the second. We want to make at least, so greater than or equal to, $600 a week. Now, how are we going to graph this? We need to get both of these into y is equal to mx plus b form, and then we'll graph it in our calculators. So let's go ahead and get these into slope-intercept form, and then we'll graph these. The first one becomes y is less than or equal to minus x plus 55. And the second one is going to become y is greater than or equal to 15 over 11 x plus 600 over 11. Let's go ahead and graph this. All right, so here we are with both of those in our equation, or in our y equals menu. Now, how do we shade a region? Well, it's actually really simple. If you press back from the very end of your equation and press back once more, you'll get to this little dot over on the side. If you press, for this one, it looks like you can change your color. We just want to change our line. And by pressing forward and back, or by pressing enter, depending on your calculator, you can choose until we get to the above or below. And this is how we decide whether we're going to shade above or below. For the first one, it was less than or equal to, meaning we're going to want to shade below. Let's press OK on that one and go down to the next one. You might have to go back until you're over this, it's highlighted again. We're going to press enter. This one we want it to be greater than, so we want to choose the triangle above. That'll let us do greater than. And now let's adjust our window. So our x-min should be 0. We're expecting to work at least 0 jobs. And our maximum, let's say, is 55. We don't know exactly how many hours we're going to work. Our y minimum is going to be 0, and our y maximum could be 55 hours as well. And then let's go ahead and graph this. So we see this area is the area that we can do for terms of hours. So blue is what we can do for hours, and red is what we can do for money. This little overlapping area in the middle is what we can do for either. So take a look at that. Make sure you understand what we did. We adjusted our window so that it would all fit, but all we were doing, we were putting in our y values, then we went over to the side and changed these little symbols until they were greater than or less than. When you're done with that, you can just press back and get back over to the normal line that we have. So that is it for this application. Why don't you go ahead and try the second application? We're looking for somebody who wants at least 10 pounds of strawberries and blueberries, when strawberries are $2 a pound, blueberries are $3 a pound, and she doesn't want to spend more than $25 for fruit. What are the equations going to be, and what is that graph going to look like? Well, the equations are going to involve strawberries and blueberries. So let's call X our strawberries, and we'll call Y our blueberries. Then we know that the total amount of strawberries and blueberries we want is going to be greater than or equal to 10 pounds. We want at least 10 pounds. Or rewritten, that's going to be y is greater than or equal to minus x plus 10. What about for price? Well, it's $2 for each box of strawberries, or each pound, and $3 for each pound of blueberries. We want to spend less than or equal to $25. Or when we rewrite this, this will become y is less than or equal to minus 2/3 x plus 25 over 3. Let's go ahead and put that into our calculators. Here we are with those in our calculator. Let's go ahead and readjust these back. So we wanted at least 10 pounds, meaning that this is going to be greater than, right? We're looking for greater than 10 pounds of blueberries and strawberries, but we want to spend less than this amount. So this is going to be the downwards triangle. It's everything underneath that. We go to our window. This time, don't think we're getting more than about, let's go a little bit higher. We'll go up to 20 pounds in each the blueberries and the strawberries and see what that gives us for a graph. So that's the amount that we can do for pounds in this little sliver in here. Let's zoom in on that. Let's adjust our window. So looking at this, we can cut off some of our maximum. Let's go down to 15, and we can definitely cut off everything for our y maximum. Now this intersecting area right here are all the possible solutions. And with that out of the way, we just have a couple more tricky graphing problems. And that's because we're going to start to include things like absolute value functions. For this absolute value function, how are we going to set up these systems of inequalities? Well, we're just going to treat these like equal signs at first. So if y was equal to minus absolute value of x plus 4, we'd go up to plus 4, then we'd go down 1 over 1 on each side, down 1 over 1, and we'd keep doing that. So down 1 over 1, down 1 over 1. And now this is less than or equal to, so I'm going to make a solid line. And it appears as if this is less than, 0 will be less than 4, so it's everything underneath. Okay. What about the second equation? We have y is greater than 2 absolute value of x minus 2. Well, the minus 2 tells us we go down to 2, and then instead of going over 1, up 1, we're going to go over 1 and up 1 times 2 because of the 2 outside here. So over 1, up 2, over 1, up 2, and so on. Over 1, up 2. And we're going to graph this. This one is dashed because of our greater than sign. And what about for this one? Where are we shading? Well, 0 is greater than minus 2, so 0, 0 works. It's going to be everything above. We want everything above this blue graph and everything below the other one. So our overlapping area is this tiny little area in here that we're going to graph. That's going to be our overlapping area. Go ahead and try this one, but keep an eye out for this x minus 3, that vertical line, and the y is minus 2, that horizontal line. So starting with this, we have x is less than minus 3. So we're going to go to minus 3. We're going to do our dashed line. And everything greater than minus 3 means we're doing everything to the right of this line. For y is greater than minus 2, we're going to do a vertical line, again a dashed line, at, or a horizontal line, at minus 2. And if x is greater, trying the point 0, 0, 0 is greater than minus 2. So we're shading everything above here. Meaning we already know we're stuck inside this top right bit, but we have to figure out what this last restraint does. Minus 2/3 x plus 4, so we're going to go over to 4. We're going to go down to over 3, down to over 3, and keep going like that. Let's go the other way as well. And we get something that looks roughly like that. We're going to draw a solid line through this because our line is greater than or equal to. And let's look at which area we shade. Is 0 going to be less than or equal to 4? It is, meaning that we want to shade this area underneath. And if we're shading in this top right area, but only everything underneath this line, that means our graphed area, or our shaded area, is this area in here. All right, that is it for this lesson on inequality systems. Go ahead and get working on the homework.